Hello and welcome to today's lesson on work and power. Our learning objectives are to use the relationship between work done, force and distance moved along the line of action of the force. That just means distance moved in the same direction as the force. Describe the energy transfer involved, recall and apply the equation for work done, convert between Newton meters and joules, and explain what power is and recall and apply the equation for power. Now, Mount Snowdon is the tallest mountain in Wales. If you were to climb up the mountain, there are several possible routes you could pick. The Llanberis path is a slow and steady ascent. In contrast, the Miners Track is a much shorter but steeper path. Which do you think would be the hardest work? Doing work in science is about using a force to transfer energy from one store to another. As an example, if you had a backpack and you lifted it up onto a shelf using a force, in this case you're doing work against gravity, shifting energy to the gravitational store of the backpack. In this example, the same amount of work is done against gravity for each bag. Each bag will have the same gravitational potential energy at the end. When you push an object across the floor, you're doing work against friction. Energy is transferred to the thermal store of the surroundings. Sometimes you can even feel the object getting hotter. Work is the transfer of energy. Work is commonly done against gravity or friction. It can be calculated by multiplying the force by the distance. Can you pause the video now and copy this description into your books? You need to be able to recall and apply the following equation for work done. Work done in joules is equal to the force in newtons times the distance measured in meters. It's very important that you always change it into meters before you do your calculations. Pause the video now and copy down the equation. As an example, we need to calculate the work done lifting 400 grams 75 centimeters onto a shelf. The first step is to change the 400 grams into kilograms, 0.4 kilograms, and then times by 10, G, to turn it into newtons. So it's a force rather than a weight. Finally, the distance needs to be converted into meters. Once we have a force of 4 newtons and a distance of 0.75 meters, we can just times these two together to get the total work done as 3 joules. Here we have 3 questions for you to practice this equation with. Remember that distance is always measured in meters, so you need to convert centimeters into meters, and force is always measured in newtons. So if you've got the value of the mass in kilograms or grams, you need to convert that into newtons first. Kilograms to newtons is just timesing by G, which is 10. And here are the answers for all 3 questions. Please check your work and mark it if you got it right. What is power? Well, power is the rate at which energy is transferred. As an example, if 2 people have equal weight and are climbing mountains via different routes, as we talked about at the start, the work done will be the same in both cases. But if one person can climb the mountain much more quickly, they are more powerful. Power is the rate of transferring energy, or the work done over time. Copy this definition down in your books and don't forget to pause the video while you do. You need to be able to recall and apply this equation for power. Power is equal to the work done divided by the time. Again, pause the video now please and copy this down in your books. As an example, if a motor delivers 600 joules of energy in 5 seconds, then the power is 600 divided by 5 for a total of 120 watts of power. Power is always measured in watts, and the time is always measured in seconds, and the work done is, as you know, always measured in joules. Copy down this table and fill in the blanks using the equation that we've just discussed. And here are the answers. Please make sure you mark your table and make any corrections before you move on. Now we're going to try and find out how powerful you are. To calculate your power, we need to find out how much work you've done whilst climbing up the stairs, and for that we need your weight, which is in newtons, kilograms times 10, and the height of the stairs, measured in meters. Times those two together and that will give you the work done. If you then measure the time, divide the work done by the time and you'll get your power. Make a note of it in your books. We've moved on from Mount Snowdon to Mount Everest now. Mount Everest is 8,848 metres high. How much work would a 75 kilogram person do if they climbed to the top of Mount Everest? You should be able to work out the work done by timesing the mass in kilograms by 10, g, and then timesing this by the distance in meters. So 75 times 10 times 8,848. The answer would be 6,636,000 joules of energy. Make a note of this if you haven't got it written down already. And now an extension question for those of you who'd like to stretch yourselves. A Big Mac contains 2,250 kilojoules of energy. How many Big Macs would you need, in theory, to climb Mount Everest? To find our answer, we need to divide the total energy, 6,636,000 joules, by the energy in a Big Mac, 2,250,000 joules, and we get an answer of approximately 3 Big Macs, assuming we don't need any energy to keep warm or anything. For this final activity, I would like you to pause the video now, copy this sentence down in your books, and fill in the gaps using the words at the bottom. And here we have the answers for you. Make sure that you go through your work and mark it, and if there are any mistakes, correct them as you go. Well, that brings us to the end of today's lesson. I hope you found this useful, and thank you very much.